Now the containers. This is the most important component of your aerosol. Your container must be able to withstand at higher pressure, because inside your aerosol there is a high pressure inside the container. That's why your container quality should be very good, that it should have the ability to withstand at the higher pressure. If instead of your steel or metal container or your glass container, if you want to use the plastics, then that plastic may not have the ability to remain stable at the higher pressure, so it may cause the blast or the explosion or the leakage. So that's why most of time we are using the metal container or the glass container with the high quality. Then in case of metal, we can use the thin plated steel, we can use the aluminum type of material, or we can use the stainless steel. So depending on your drug delivery to the nasal or to the topical, we can choose your type of metallic container. Then glass type of containers also are used for the aerosol purpose. Generally uncoated glass, then plastic coated glass is also used. Now what is the utility or the specialty of the thin plated containers? Generally thin plated steel containers are having the generally sheet of the steel plate is prepared, and firstly that steel plate is coated with the electrolyte process. Actually when such kind of coating we are giving, so there is no interaction of that steel container and your product will be happen. So that coating will avoid the contact of your drug with your container. So just for protection purpose, we have to coat your thin plated steel container to avoid the corrosion. That's why we have to coat that container from the inside. And then we are preparing your aerosol container. Generally while preparing the aerosol container of the steel, your manufacturer will prepare into the three parts. Then that three parts will be joined to each other. Neck part will be prepared differently, then middle part will be prepared differently, and bottom part will be prepared differently. And then after that they will join with the soldering or the welding process. Nowadays modified welding process is there, that is called as the soldering process. So by this process we can join without any kind of scratch. So completely your container will be joined to each other. Then aluminum containers are there. Generally aluminum containers are used for those two aerosols which are used for the nasal cavity purpose as well as for the topical purpose. Then this kind of aluminum containers are prepared by the impact extrusion process. Aluminum containers are lightweight. They are not that much heavy as your thin plated as well as the steel containers. So that's why they are, you can say, very easy to transportation. So the cost will be reduced. Then stainless steel containers. These are used for the specially inhalation types of aerosols or for the nasal drug delivery system. Advantage of stainless steel containers is that they are very strong compared to your other type of aluminum as well as your other container material as well as glass. They are having the resistance to your corrosion, as well as most of product is stable inside your steel container. There is no any corrosion as well as the interaction of the product with your steel. Then there is no need of the coating from the inside of your container. But stainless steel container are having the disadvantage that they are very costly compared to the aluminum, glass. Then glass containers. These glass containers are preferred when we want to give the different shape to your aerosol container. So it will give the aesthetic value or the attraction. So most of your aerosol containers which are prepared by the glass, they are having the attractive shapes. As well as your glass container is having the one advantage that there is no any incapability or the interaction of your glass container with your drug is occur. So basically they are safe with your product, or your product is safe inside the glass container compared to your metallic containers. These containers are limited to products having the lower pressure. Generally when we are preparing the aerosol system containing the maximum 33 psi pressure, So up to the 33 psi pressure we can use the glass container. Then if you want to maximum pressure or your system pressure is high, then at that high pressure we cannot use the glass container because they may cause the explosion or the breakage. Then glass containers are used for the topical type of aerosols as well as the meter dose aerosols. This kind of glass containers are generally having the two types: uncoated glass containers as well as the coated glass containers. Uncoated glass containers means inner side of that container is not coated, so that is called as the uncoated. And plastic coated glass container means the glass container is previously coated with the plastic thin layer, so to avoid the any kind of you can say interaction with your drug, as well as to give the extra protection to your aerosol container, so it may cause the or it may reduce the chances of the breakage of your container. So this is the two types of your glass container. Now another component of your aerosol is the valve. So this valve is responsible for your spray pattern. Now these valves are very easy to open and close. Just we have to press your valve or that button. Then they are having the ability to deliver your content into your desired spray pattern form, as well as you can produce the foam form, solid stream form. So as you are required, so in this form your valve will deliver your spray pattern. So it can give your desired amount of medicament also. It means if you want some particular amount of drug should be delivered to the patient, so such kind of adjustment is also possible with your valves. Types of valves. These valves are having the two types: continuous spray valve and metering valve. Continuous spray valve means as like as your normal spray valve, and metering valve means there is we can measure your particular dose of your content. See, this is your valve assembly. Under the valve assembly we are having the different types of small components. First is the orifice, then actuator, then stem, then gasket to avoid the leakage of the gas or the leakage of your aerosol content, then valve cup, then spring for the continuous lifting of your valve towards the upper side, then valve housing, and then deep tube. See, these are the different components are attached to each other. You may have seen this kind of valve assembly into your various kind of spraying devices. Then continuous spray valve. This is used for the topical aerosol purpose. Generally for the, you can say as an anti-inflammatory purpose we can use. At that time we have to use the continuous spray valve. So this continuous spray valve is not having the metering or the measurement of the dose. So they can deliver your dose till you are pressing your button or the switch. So it consists of the ferruli or the mounting cup, then valve body and housing, then stem, dip tube, gasket and spring. Most of components are same in case of the both sprays. Then ferruli or the mounting cup. Generally ferruli or the mounting cup is used to attach valve to the container. Generally it is made up of the tin plated steel or the brass. Then valve body or the housing. Valve body or the housing is made up of nylon or the derailing type of plastics. Then stem is there. Stem is made up of nylon or the derailing. So these are the different kind of components they are preparing your valve assembly. Then gasket is there, spring is there, and dip tube is there. Dip tube is nothing but we can say one type of polyethylene type of material is used, and by using that material we are preparing that tube. That tube is responsible to carry out your material from the container to the outside or to the up to the valve. Then metering valves are there. Metering valves are nothing but such kind of valves. They are having the ability to dispense the required quantity of the drug. Approximately 50 to 150 milligrams plus minus 10% of liquid may be delivered at a time when we are pressing it. So that is called as the metering valve. Now actuator. Actuator is nothing but the topmost part of your aerosol container. So this is called as the actuator. I have shown here figures. There are the different types of actuator with the orifice. Depending on your required spray pattern, we can have the different type of actuators. There are the spray actuators, foam actuators, solid stream actuators, and special actuators. See, these are the spray actuators. Spray actuators is nothing but to use for the topical preparation purpose, and generally we are delivering the antiseptics as well as the local anesthetics and spray on the bandages. So for that purpose we have to use the spray actuators. Then your foam actuators. Generally foam actuators are used for the we can say for the your shaving cream purpose. In that case we have using the foam actuators. Then solid stream actuators are there. These are required for the dispensing the semi-solid type of products such as ointments. Then special actuators are there. These are used for the specific purpose. It delivers the medicament to the appropriate site of action. So they are having the long tube at the your orifice. So at the particular space or the your particular organ like your teeth or inside the nose or inside the throat, you can deliver your product. So they are called as a specific type of actuators. See, these are the different spray patterns can be obtained by using your actuators. See, these are the tubes are there for delivering at the specific type of your drug. Then meter dose inhalers, or they are called as the MDI. So these are nothing but your specific type of actuators are having the metering action, or they can able to measure your particular dose when we are pressing it. At once, suppose we have pressed your button, then it will deliver the required amount of dose, or how much dose should be expelled from your container, that can be adjusted. See, these are the pictures of your meter dose inhalers. These are the marketed pharmaceutical aerosol products. Generally, most of time we are using it for the asthmatic patients. Now formulation of the aerosols. Generally your aerosols is consist of the two type of essential components. First component is the product concentrate or the active ingredient or your drug. Then second component is the propellant. Propellant is already we have seen. Now what is the product concentrate or your drug? Generally your drug is in the form of your liquid, or some drug are maybe dissolved, or some drug we have to we can say suspend in the form of suspension. So they are called as the product concentrate. The active ingredient or the mixture of active ingredients as well as the other necessary agents such as solvent, antioxidants as well as the surface acting agents sometimes we have to add, so that all the surfactants, antioxidants, solvents and drugs, they are all called as the product concentrate. As like as in your oral drug delivery system, suppose we are preparing the solution, suspension or emulsion, so at that time we have to add the drug and then we have to dissolve the drug into the solvent. So we require the solvent or the vehicle, as well as we have to add the antioxidant. So in this manner, in the aerosols we have to prepare the such kind of product concentrate or the mixture of that total material, that is called as the product concentrate. And then another thing is the propellant. Sometimes we are using the single propellant, or sometimes we are using the combination of the propellant. These propellants are nothing but your volatile substances. They are having the ability to develop the pressure inside your container, and along with your propellant and your active drug, we have to mix them and we have to add inside your container. Generally various kind of surfactants we are using along with your active ingredients, and we have to match the HLB values with your propellant. Then the propellants are selected to give the desired vapor pressure, solubility as well as the particle size. So depending on your requirement, suppose you want to give it onto the skin, or you want to deliver your drug into the nasal cavity. So depending on that, we have to select your propellant. Then when we are mixing your propellant plus your active ingredient, your solvent, so generally that system or that mixture is called as a particular type of system. So depending on that solubility of the drug and depending on your propellant, we may have the different type of system, or the product concentrate may have the different type of systems. So what are that systems? That systems are nothing but we can say having the two systems or three systems as like a system. Now types of your that system. The types of aerosol systems are solution system. It means when we are dissolving your drug into your directly propellant, then it is called as the solution system. Sometimes you may require to use the water as a vehicle. In that water we are adding your drug, and then that water and your propellant we are adding into your container, then it is called as the water based system. See here, your propellant and water is not getting mixed, or they are always, we can say, immiscible. So it is called as a two-phase system. Then suppose you are dispersing your drug into the directly propellant, so they are called as a suspension type of system. Then another system is nowadays familiar, that is called as the foam system. When you are pressing your wall, so at that time you will get the, we can say, foam outside your aerosol. So that's why it is nowadays very much you can see utilized, that is called as the foam system. So under the foam system also there are the four systems. First one is the aqueous stable foam system. Another one is the non-aqueous stable foam system. Type is the quick breaking foam system, and fourth is the thermal foam system. So these are the, you can say, four foam systems are available under the foam system. Then another is the intranasal aerosols. Now what is the solution system? Generally this system is preferred as a two-phase system, or it is also called as two-phase system. As I have already told you that your drug is dissolved into the directly propellant, then your propellant and your drug is becoming the one system, and whatever the gas is developed inside your container because of that your propellant, so that gas is also called as one system, and another is the your drug plus propellant in the form of liquid. So there are the two components inside your, or the two phase inside your container. That's why it is called as the two phase system. So in case of emulsion, suppose we are adding the oil in water, then it is called as the biophysics. So in your solution system, your drug plus propellant in the dissolved form, that is one component, and your gas is the another component. So this both are called as a two-phase system inside your container. So this is called as the solution system, and solution system consists of the two phases. Then most of we can say propellant are used up to the, we can say 100% or up to the 50-50%. Generally active drug plus your propellant is selected, your drug is dissolved into the propellant, and then it is filled inside your container. Generally we can use the sometimes ethanol, acetone as well as propylene glycol, and then we are adding it into the propellant. Generally ethanol, acetone, propellant, when we are using as a solvent, your drug will be quickly dissolved, and then your acetone or your ethanol, it will be miscible with your propellant. So that's why they are having the only single phase, and your gas is produced after filling inside your container. So that gas of that propellant is called as the another system. So that's why in case of solution system there are only two phases. This is the formula for the inhalation aerosols: isoproterenol hydrochloride, ascorbic acid, ethanol, propellant. Then water-based system. Generally in case of water-based system we are using the large amount of water, and in case of water-based system it produces sometimes spray, or sometimes it may produce the foam. Generally we are using the surface acting agent also in the concentration of 0.5 to 2% and your drug. Generally in case of water based system, it may have the 3 phases. Now suspension system. In case of suspension system, there is a dispersion of active ingredient into the propellant or the mixture of the propellant. Sometimes your drug, suppose we are dispersing as your suspension, so directly we can disperse your drug into the propellant, and the size of that drug is very small, generally into the 1 to 5 microns. Generally it decreases the rate of settling of the dispersed particles when we are reducing the size, and we require to add the surface acting agent to avoid the settling of the drug. The epinephrine bitartrate is the choice of drug for the such kind of system. Now foam systems. Generally in case of foam system, we are using the emulsion type of system. So in the foam system, it consists of your active ingredient as a drug. Then sometimes we have to use the aqueous or non-aqueous vehicle, then surface acting agent as well as your propellant. So it is also 3-phase system. Generally we have to take your active ingredient and your other surface actant as well as the propellant, and then we have to add into the container. Examples of this non-aqueous system is the glycerol, emulsifying agent and hydrocarbon propellant. Then quick breaking foam. Generally in case of quick breaking foam, when we are expelling the product from your container, it will produce the quick your foam, and immediately that foam will be break down. So that's why such kind of system is called as quick breaking system. Then thermal foams are there. Actually thermal foam are nothing but the such kind of foam when we are applying on the skin, they are causing the warm feelings. Generally thermal foam is used for the shaving cream purpose or the shaving purpose. Then intranasal aerosols are there. Generally intranasal aerosols are intended to deposit the medicament into the nasal passage for the local or the systemic effect. See manufacturing of your aerosols. First of all, you have to select the empty can, then we have to add your content of that aerosol container, like your propellant as well as your drug, and then we have to fix your wall or that total assembly along with your deep tube, and then after that it will be ready for the application purpose. Now the manufacturing of the pharmaceutical aerosols. When we are prepared your product mixture or your active ingredient we have selected, suppose we have selected the related other ingredients like your solvent as like another material like antioxidant and your propellant. Then after that we have to add it into your container. Now addition of that all the ingredients inside the container, that is the main procedure. So there are the 3 ways or the 3 methods for the filling of your aerosol container. So first method is the pressure filling apparatus method, another method is the cold filling apparatus method, and another third method is the compressed gas filling apparatus. Generally with the help of apparatus only we can able to fill up your propellant plus drug inside your container. So when we are using the pressure filling apparatus, generally it consists of the burette. Inside that burette we have to fill up your material, and at the downside of that burette there is the you can say outlet which is connected directly to your container, and with the help of that burette we can fill up your material inside your container. Inside that burette generally we have to develop the high pressure. Because of that high pressure, whatever the propellant is present, it is always remaining inside the liquid state and easily we can pass into your container. So this is the first method, that is called as the pressure filling method by using the burette. Now advantages of such kind of pressure filling system. Generally with the help of this pressure filling system or the pressure filling method, we can able to fill the solutions, suspensions as well as emulsions inside your container with the help of chilling those, and there is no any we can say cooling of the drug is occurred. Only because of the high pressure we are converting your propellant into the liquid state, and then only we are able to press in add it into the your container. There is, we can say, contamination of the moisture is very less. Then high production speed is achieved. It means we can very fastly fill up your other containers. Disadvantage of this method is that certain types of metering valves can be handled only by the cold filling process. It means when your propellant is highly volatile, so in that case it is not possible to use the pressure filling system. See, this is the burette I have shown here. Inside the burette we have to fill the your material, and downside we have to attach the your can or the your container, and then it is filled with the high pressure inside your container. There is no any leakage is occur, and automatically it will be sealed, or your upper wall as well as your total assembly will be fixed here itself. Then cold filling machine. Generally cold filling method consists of the reducing the temperature of your propellant. When you are reducing the temperature of your propellant, it will not convert it into the gas, so it will remain inside the liquid state. So that's why easily we can fill up it inside your container. So while filling with the help of this method, we have to reduce the system pressure, system temperature, and then we have to fill up your total propellant plus your drug inside your container. Generally it is very easy process. Disadvantage of this method is that aqueous products, emulsion and other products which are adversely affected by the your cold temperature, they cannot be handled by this system. Means some drugs as well as, like suppose water based system is there, so they cannot be handled by this system, because your water based system will convert it into the ice, or where water is present it will convert it into the ice, so we cannot fill up it. So here such kind of emulsions where water is present, or some solutions is there where water is present, so that kind of aerosol content cannot be filled with this method. See, this is the cold filling apparatus. Then compressed gas filling apparatus. Now what is the compressed gas filling apparatus? Generally here compressed gas filling apparatus have the high pressure, and it will reduce the we can say pressure, and it will reduce the wall. So because of the high pressure, your all the propellant will always remain into the liquid state. That's why we can easily fill inside your container. So there is the special we can say compressor is there. Inside that we can use the your all the material we can compress. Because of the compression, gas will be eliminated, or it will convert it into the liquid, and easily you can fill up inside your container.